The diagram shows a circle, centre O and radius 12 centimetres. The points A and B lie on the circumference of the circle and form a rectangle with the points C and D. So in other words, there's a rectangle here. I'm not going to draw it in just in case it confuses the diagram. The length of AD is 8 centimetres. Okay, we can see that. And the area of the minor sector AOB, that's this sector here, is 150 square centimetres. We want to show that the angle AOB is 2.08 radians. That's this one just here. Correct 2 decimal places. Okay, so we know that if we're working in radians, that the area is a half r squared theta. So 150 is going to be a half times 12 squared times theta. So 150 is, 12 squared is 144, half of that is 72 theta. So theta is equal to 150 divided by 72. And we can calculate that. So 150 divided by 72 is 2.083 recurring radians. We don't actually need a mark for radians. Radians are just numbers. But I sometimes use a C. Find the area of the shaded region ADBC. So that's this region here, obviously. And so we might need to think about how to do that. I'm going to draw that line back in that I was just drawing in just now. So we've got a rectangle here, and what we'd like to do is take the segment away from the rectangle. So there's a few things we're going to need to know here. We're going to need to know this length, and we could do that using the cosine rule in the triangle, because that length will be the same as AB, which I've drawn in. And so once we've got the rectangle, we can take away the segment. Okay, we can strategize that. So the area shaded is going to be the area of the rectangle, take away the area of the segment. So that's our overall plan. Okay, so let's use the cosine rule. AB squared, so that's this length down here, is going to be 12 squared plus 12 squared minus 2 multiplied by 12 multiplied by 12 multiplied by the cosine of 2.083 recurring radians. So that's just using the cosine rule there. So we can work out AB on that basis. And so let's just make sure my calculator's in radian mode. So radians is 4. And so what do we get? We've got 12 squared add 12 squared. Take away 2 times 12 times 12 times the cosine of my last answer. And then we need to square root that. So that gives me 20.718. And so the area of the rectangle is going to be 20.718 multiplied by 8. And then we want to take away the area of the segment. Well, the area of the segment is going to be the area of the sector, take away the area of a triangle. So the area of the sector, well, we were given that in the question. That was 150, so at least we don't have to work that out. And the area of the triangle is going to be 1/2 times 12 times 12 times the sine of 2.083 radians. We're in a position now to just calculate this. So we've got that answers on there, so to multiply that by 8 and take away 150, take away 0.5 times 12 times 12 multiplied by the sine of 2.083, and that gives me 78.5 centimeters squared. So finally we want to find the area of this shaded region. So well, we know that's 8. We've worked this one out, that's the 20.718, and that's 8, and then all we need is the arc around here. So the perimeter is going to be 8 plus 8 plus the 20.718 plus the arc length, which is 12 multiplied by 2.083, because we know it's just r theta if we're in radians. And we're in a position to calculate that straight away as well. So we've got 16 is the 8 plus 8, add 20.718 plus 12 multiplied by 2.083, and that's going to give me 61.7 centimeters